In this lesson, we're going to learn about the gradient of a straight line. So the gradient, or slope, is the measure of the steepness of a line, and we use the letter m for gradient. So if we have our straight line here, the gradient is equal to the vertical rise over the horizontal run. And another way of saying this is the vertical rise is actually just the change in y from one point to the other, and the horizontal run is equal to the change in x from one point to the other. Now it's important to note that the gradient will be the same at every point along a line because the steepness is the same as you go along the line. So from this equation, the change in y over the change in x, we can generalize this to find the equation for the gradient. So if we have 2 points, P1, which would be x1, y1, and P2, which would be x2, y2, we can find that the change in y is equal to y2 minus y1, and the change in x is equal to x2 minus x1. So that from that we can find the the equation for the gradient. So y2 minus y1 over x2 minus x1. In this case, let's see, y2 would be equal to 4 and y1 will be equal to 1, so the difference there is 3. And x2 would be equal to 4 and x1 would be equal to 1, so that's also 3. So we would have 3 over 3 and that's equal to 1. So our gradient would be equal to 1 for this line. Now we can try and do some examples. So find the gradient of the line going through the point 2, 3 and the point 6, 5. So we get our equation here and then we just substitute in it. So y2 is equal to 5 and y1 is equal to 3. And then x2 is equal to 6 and x1 is equal to 2. From there, we do our math and we simplify. So 5 minus 3 is 2 and 6 minus 2 is 4. We simplify our fraction to get 1/2, and that is our gradient. Here's another example. Find the gradient of the line going through -2, 2 and 4, 1. And there's no particular reason for this, but we normally say that the leftmost point is point 1 and the rightmost point is point 2. But if you want to reverse that, it's okay, you'll still end up with the same gradient. So here's our equation, and let's substitute into it. So we have y2 is equal to 1 and y1 is equal to 2. x2 is equal to 4 and x1 is equal to -2. So don't forget that negative or it'll change your answer. From there, let's do the math. 1 minus 2 is equal to -1, and 4 minus -2, so you take away a -2, which means you just add to it, so 4 plus 2 is 6. So our gradient in this case is -1 over 6. Now we can generalize a bit, so we can say that the gradient will be positive if, as we increase our x values, we also increase our y values. So the blue line there will be will have a positive gradient. So any line that's slanted going upwards as you go onwards will be a positive gradient. And then you'll have a negative gradient, like the green line, if as x is increasing, y is then decreasing, so getting a smaller value. Another good thing to know about gradients is that the steeper the line, the greater the magnitude of the gradient, or the bigger the value of m. So in this case, we would expect that the blue line should have the biggest m value, and the gray line should have the smallest m value. So why don't you pause your video right now and try and find the gradient for each of the 3 lines by picking 2 points along each line. Okay, great, you're back. Okay, so first let's try and calculate the gradient of the gray lines. So for all 3 of them, I'm going to use the point 0, 0 because that just simplifies my calculations. And for the gray line, we're going to use the point 3, 1. So we plug it into our equation, and I end up with 1 minus 0 over 3 minus 0. And so my gradient or slope is equal to 1/3. Now for the green line, I've used the point 1, 1 and 0, 0. So plug it into my equation. I have 1 minus 0 and 1 minus 0. 1 over 1 is equal to 1. And finally, for the blue line, I've used the point 1, 3 and 0, 0. Plug it into my gradient equation. I get 3 minus 0 over 1 minus 0, which gives me a gradient of 3. So let's check it. Is the steeper the line, the greater the magnitude of the gradient in this case? The steepest line has a value of 3, And the least steep value has a gradient of 1/3. Yep, that looks about right. Perfect. Now we're going to look at vertical and horizontal lines. So a horizontal line, our green line, if you plug in the equation for the gradient, you'll always have a value of 2 for your for your y value. So on the top of your equation, you're always going to have 2 minus 2, which will always equal 0. So a horizontal line will always have a gradient that's 0. A vertical line, on the other hand, works a bit differently. In this case, it's the x value that always has the same value. So we'll always have on the bottom a 2 minus 2, which equals 0. So we divide by 0, which we actually can't do, can we? So a vertical line has an undefined gradient. Okay, so now we're on to the why do we care portion of this video lesson. This is how we can actually use a gradient in a real life situation to find information that we need. So in our question, Tegan ran the 100-meter dash in 10 seconds. What was her average speed? Now you can see the graph there. We're doing distance versus time this time instead of x and y. So if we found the gradient would actually be distance over time, which is our equation for speed. Perfect. All right, so let's find our normal equation, y2 minus y1. In this case will be distance 2 over distance 1, and x2 over x1 in this case will be time 2 over time 1. So let's plug it in. We've got our 100 minus 0 over 10 minus 0, which gives us 10 meters per second. So when we're doing an application question where there are units, we always have to remember to put in the meters per second at the end. And in a question that's written in word form, we always have to answer it with a sentence. So Tegan's speed was 10 meters per second.